42, so everybody please turn to page 153. Put today's date on top of the page. Okay, today's another wedding. We're going to marry 2 lessons together. We'll continue to review lesson 31, and then we're also going to take it to the next step. Okay? Nice, easy Monday morning lesson. So, Chin is buying beverages for a party, which are individually packaged and come in packs of 8. Let P be the number of packages Chin buys, and T be the total number of beverages. Excuse me. The equation T equals 8P can be used to calculate the total number of beverages when the number of packages is known. Determine the independent and dependent variable in this scenario, then make a table using whole number values of P less than 6. So step 1 is to determine the independent and dependent variables. Step 2 is to make the table. How nice, they already labeled the tables for you. They even gave you the equation already. So if we have 0 packages, don't get tricked. The tables are going to start at 0. So when the number of packages is 0, how many beverages do I have? 0. If I have 1 package, how many beverages do I have? 8, because there are 8 beverages per package. Per means to multiply. So 2 packages, 3. Okay. So what is my independent variable? What is my independent variable? You have to write this on the side next to your table. So the dependent variable, because the number of beverages depends upon the number of packages. I don't know how many beverages until I know the number of packages. Any questions on that? So now here's where we're going to take it to the next step. Do you remember way back in Module 1 when we were doing ratio tables? And if you think about it, this is a ratio table. We have a part-to-whole ratio, in a sense. Okay? Well, not quite, but that idea. We could have extended the table, but what's another way that we could keep seeing more quantities, where we could keep it going visually? Yeah, we can graph this information. We're going to do it a little bit differently than we did it in Module 1, but we're still going to take our tables and plot them all on the graph. So let's start with our heading. We're looking at the beverages for the party. I don't like that they don't have the X and Y axis. Make sure you label your X and Y axis. Now, your independent variable will always go on your x-axis. Your dependent variable will go on your y-axis. You could do it the other way. You would still have the information there. However, it's technically correct when you have your independent variables on your x-axis, your dependent variables on your y-axis. Remember, you need your 5 labels, your heading, your x, your x-axis label, your y-axis label. You can use different scales to label your x and y-axis. So we counted by 1s on the x-axis, counted by 8s on the y-axis. God bless. And now we can plot our points. But here's where it's going to be different. We are not connecting the dots. Because we have to buy whole packages. We're buying whole packages. So we're not going to see the ones in between. So we're just plotting our points. I like this next example because instead of making the graph, we're going to read it now. I like this one. It's a little different. So let's use the graph to determine which variable is the independent variable and which is the dependent variable. Then state the relationship between the quantities represented by the variables. So it looks like we went on a road trip. That's what the title says, road trip. My x-axis is showing the number of hours. My y-axis is showing the number of minutes. So I can see how many miles I went each hour. So what is my independent variable? What is my independent variable? Mm-hmm.
Number of hours.
Yep. And what's the dependent variable? What depends upon how many hours on in the car?
The number of hours.
Yeah, or calories, but yeah, number of miles. Me, I go more by, number of snacks I have to pack.
Oh,
They're going by miles. That's part of a road trip, the food. I'm trying to answer questions. What is the relationship? Let's write an equation. If our hours is H and our miles is M, what would our equation be? What do I have to do to my H to get it to equal the M? So for every 1 hour, we went 50 miles. So for every hour, we traveled 50 miles. You learned that in science during scientific method. Writing your if-then statements in your conclusions. The relationship. When you see the word relationship, you have to include the two quantities. Stay with us. So what did I do to my hours to equal my miles? I did 50 per hour.
2H.
Not 2. How did I get from 1 to 50? Or 2 to 100? 3 to 150? Right. I did 50. Then I dropped the eraser. 50 per hour. Per means to multiply. So I took my 50 times 1 hour equals 50 miles. 50 times 2 hours equals 100 miles. 50 times 3 hours equals 150 miles. So I did 50 miles per hour. Okay? Try number 1 on your own. So each week, Quentin earns $30. If he saves this money, create a graph that shows the total amount of money Quentin has saved from week 1 through week 8. Write an equation that represents the relationship between the number of weeks that Quentin has saved his money, W, and the total amount of money he has saved, S. Then name the independent and dependent variable. Write a sentence that shows this relationship. So let's go back and see what we need to do. We need to, 1, create a graph. 2, write an equation. 3, name the independent and dependent variable. And 4, write a sentence. Excuse me, we don't have to go in that order. Now there's one thing I don't like here. It says weeks 1 through 8. We're going to do weeks 0 through 8. For your homework, every table will start at 0. Okay? Alright, so let's label our table. So here we have what? What's our first column? Number of weeks, W. Total saved. We put the $sign here so that we don't have to label it through our table. It says weeks 1 through 8, but we're going to start at 0 because when we're making a graph, we're starting at 0, whether it's the origin. So week 0, we're assuming he had no money in the bank. He started fresh. They didn't tell us he had any money to start off with. And then $30 each week. So your table has enough rows to fill it in. But if you notice, the graph that they gave you did not give you enough across your x-axis, so you'll just graph whatever you have room for. You don't have to extend that graph paper. So go ahead, put your 5 labels, your title, your x, your y, label your x and y axis, and then just plot the points. We started our origin, 0, 0. I think you have to stop yours at 5 or 6. I have to stop mine at 8, and that's all the week that we have. Now again, we're not plotting the points. We're looking at whole amounts. So now what would our independent variable be? What's the independent variable? Yeah? What's our dependent variable? What's our equation?
30W equals S.
Good. 30W equals S. They said to write a sentence. I'd rather see you write an equation. So I'm making an executive decision. We're going to write an equation instead of a sentence.
Yay.
All right, let's continue. Any questions? Where did the 30 come from? Where did the W come from? How come we wrote it that way? No questions? You have all your labels on your graph. You did not connect the dots. Okay. Let's have you try number 2 on your own. For real on your own this time. We kind of did that last one together. Maybe I'll start you on this one because this one has another little curveball in it too. Zoe is collecting books to donate. Oh, good for Zoe. She started with 3 books and collected 2 more each week. She used the equation, her number of books equals 2W plus 3, where B is the total number of books, W is the number of weeks she had been collecting. So it looks like she collected 2 books per week plus the 3 that she had when she started. Name the independent and dependent variables. 2, then create a graph to represent how many books Zoe had collected when W is 5 or less. So we know how to set up our table. So our first column is our independent variable. So we have number of weeks. And then number of books. We're starting all of our tables with 0. But she did not have 0 books when she started. How many books did she have when she started? She had 3. This is like that plant question from the test. So now on week 1, she had her 3, but she collected 2 more. So it was week 2, 3. So now when you make your table, just think about what interval you're going to use on your y-axis. I can't count by 3s. I'll miss the 5, the 7, the 11. We don't have enough room to count by 1s. So you can actually go up by 2s on your y-axis, and then you'll just be plotting in the middle. So take a minute now, draw your graph, identify your variables, and then we'll go over. You could have counted by odd numbers, 1, 3, 5, 7, but the problem with that is if you went from 0 to 1, that has a space of 1. And then you went to 3, now you have intervals of 2. You have to keep your spacing even. So we can't count by just odd numbers. We could have counted by 3s, 3, 6, 9, then each space would have been worth 3. So we had to count by, we could have counted by 1, but then we wouldn't have had enough room. Make sure you have your X. Make sure you have your Y. Make sure you have your 3 titles. Questions on this? All right, what's our independent variable? What's our independent variable? And our dependent variable. And they already gave us the equation, which was nice of them. All right, but now for the next one, we don't have an equation. So that's for you to write. So Eliana plans to visit the fair. She must pay $5 to enter the fairgrounds and an additional $3 per ride. Write an equation to show the relationship between R, the number of rides, and T, the total cost. State which variable is dependent and which is independent. Then create a graph that models the equation. Okay, so 1, write an equation. 2, state the variables. 3, make a graph. Where's the table? It didn't tell us to make a table? Well, we still need to make the table, though. So make a table. Huh. Alright, go. Alright, so let's see. So we have the number of rides, R, and the total cost, T, in dollars. You write the unit in your heading. You don't have to write the dollar sign all the way down. So remember, we're starting our tables at 0. So even though we didn't go on any rides, we still had to pay $5 just to walk in. So $5 to walk into the fair. But then, yes, I want to go on a ride. I love the roller coaster. So then for each ride, it's another $3. But we can't forget that $5 that it costs to walk in. So are there any questions on the table? All right, so now for our graph, we have our 3 headings. We have to label our y-axis and, God bless you, our x-axis. And let's identify our independent and dependent variable. What's our independent variable? Sure.
Why are you going up at 2s on the y-axis?
What do you want to go up by?
I don't know, like I put like 5 and then I did 8, 11.
You have to have even spaces. So each one of these is 2 apart. If you went up differently, then you're jumping by a different scale. Remember when we did our coordinate grids, we always have to have the same intervals. We have to go out by the same amount. And you want your spaces to be as small as possible, so it's as detailed as possible. So you want to jump by the smallest amount as possible. We can't go 0, 1, 3, 5, because then I have 1, 2, 2, 2, 2, 2s. So 2s fit, even though I had to plot them in between, that's okay.
Their graph paper's not as big as yours, so if
Yeah.
they get 2, they only get to 12. So they
Oh, okay.
I think that's why they're getting confused.
Oh, all right. All right. Maybe go by 3s, but then it's still a little awkward going by 3s.
Isn't there like a symbol that you can like draw it?
Like a break, yeah, but that's like when we're jumping to huge numbers. All right, so our independent variable is what? And our dependent variable is, what's my equation? That's what I really want to see. What's the equation? $5 plus $3 per ride equals our total cost. Very good. Very good.